And good afternoon again, and glad to be back with you guys. This presentation will be the regular stuff that you are used to. This time will be about external quality controls or external quality assessment, however you'd like to call it. We will speak about why we would do it and how we would do it. Okay. So the presentation will briefly speak, as I said, briefly about why would you do the external quality control, and then the how. The how will be the bulk of this presentation. So the why part of external quality assessment or external quality control, again, as you'd like. So first of all, what does EQA stand for? External quality assessment, or it's also called proficiency testing. And as defined by the ISO, it's very simply something that you would use to check the quality of the results that you release for your patients, okay? But this thing that you are using to verify the quality is provided by an external agency or a third party or simply someone who is not the manufacturer you are buying from, so to speak. Now, if you remember from previous presentations, just a quick reminder, why did we say that we would do this? Why would I go buy from a third party? Why would I spend my money on this as a lab? Why would I bother, with all the corrective actions that will come with it, etc., etc., etc. The point is, okay, we have QC in the lab, but again, if you remember, there's a slide from previous presentation, we said your regular QCs, your internal QCs, are not a very great tool to check the accuracy of your results. They are good for a precision. They give you a generally okay idea that, okay, you are generally accurate, but they are not that good for this particular purpose, that is assessing accuracy. We have much better tools, which are EIQC or externalized IQC, which is my expert QC, and external quality assessment, which we will be talking about. Okay, they are much better for you to assess your accuracy than your regular internal quality control. Okay, so again, from previous presentation, we said that the external quality assurance checks the accuracy of the results of the lab. How? By comparing your results to other labs who have done the same survey or run the same sample on the same analyzer and using the same reagent. We'll speak about the specifics, of course. Now, on the opposite side, external quality assessment is not a good tool for you to assess the precision of your analyzer because usually you would run these samples just once. And you do not anyways usually have enough volume to run a precision assay. Precision assays, they usually require you to run a sample multiple times, which is not something that you normally would do with an external quality assurance assessment sample. Now, the other question is, why would I do it? Okay, I can check my accuracy, that's fine, but QC is fine for me. Sometimes you don't really have the choice. For example, if you have a CAP accreditation, for you to get your accreditation, you are required to have an external quality assessment. Sometimes your local regulations from Ministry of Health or whatever authority you have in your country, they might require you to have an external quality assessment. For some countries, for example, you have to have an ISO accreditation. ISO accreditation requires you to have an external quality assessment. So usually the reason for you is for you to use the external quality assessment is because you have to get the accreditation. Very few labs take external quality assessment by choice because they want to improve their accuracy. So these are just very, very few labs. All right, so now once you understand the why of why do we do external quality assessment, the how becomes a little easier because you understand the purpose of the EQA. Now, how do we deal with this whole EQA thing? Why is it different from my QC? What is different? At the end of the day, it's just a plasma that has values that I run and I get results. How does it differ? There is a very critical difference. Now, just like your QC, you get it from a supplier, but the QC comes from the manufacturer. It can come from a third party, but there's a critical difference again. For external quality assessment samples, they almost always come from a third party, okay? Someone who is certified as an EQA provider. You cannot be an EQA provider if you are not certified for this purpose. And this is mostly third parties. In the Stago case, you have Equalris. It's an EQA, okay? It's not a third party, it's a Stago. Stago is selling to Stago analyzers, but the Stago Equalris is certified to be an EQA provider. Anyways, so the EQA provider will send you a sample. You have no idea what are the results that are supposed to come from this sample. Okay, so you receive these samples, then you run them in what is called a blind assay. Blind assay means I run this sample or this plasma or this vial as a patient sample, but I have no idea what the results are supposed to be. So the whole point of EQA is to mimic or to be testing the process that you have in the same way that you are running a patient sample, because the whole process of EQA is to test your capability of reporting good patient results. So you must run it in the same way as you run a patient sample. Okay, so we run this EQA material as a patient sample, then we report our results or findings to the same provider that gave us these samples. Then this provider will give us back a report, and the provider will say, your results are good in comparison to others, or your results are bad in comparison to others. All right, again, we'll speak about the specifics. So, this point, we have already spoken about it. Most labs would use the AQA for regulatory requirements and or accreditation. Now, what are the providers that I need to use? This depends on the regulation that you have in your country or the accreditation you are going for. So for example, CAP requires you to use only CAP material. You cannot be CAP accredited and use, for example, Biorad materials. They do not accept that. So in this case, the provider that you have to use, if you have a CAP accreditation, is CAP itself. If you have an ISO accreditation, for example, you can use materials from Biorad, from Randox, from RCPA, whatever it is. So this depends on the type of accreditation that you have and on the local regulations in your country. So it depends on your situation as a lab. There is no one rule that fits all. Okay, so I ordered from CAP, I ordered from Randox. How often do I receive these samples? Do I run it every month? Do I run it every 2 months? How often? Are there standard number of months that I have to run an EQA sample in? No, this really depends on who you are working with. If you are working with Biorad, for example, some samples are provided every month or every 2 months, depending on the survey, depending on your accreditation. So there is no specific standardized amount of months that you need to run EQA in. It depends quite a lot on the survey and on your local regulations. So CAP, for example, provides some surveys every 4 months. Biorad, for example, can provide you surveys every month. So it really depends. There is no one size fits all. So the points that we will be covering after this brief introduction is, how do I interpret the report of the EQA that I get? What are the less common types of EQAs that I get? You know, the typical type of CAP samples, for example, or Biorad samples. You get the sample, you run it, you get the result. It says you're good, you're bad. But there are other types. One of them is CVL program, or calibration verification linearity. We'll speak about it. Then, what are the common issues that you might face when you run an EQA survey? And what are the solutions that you can use to handle these problems? And finally, we'll have some frequently asked questions, FAQs. For the report interpretation, there are some basics that you need to understand before you can deal with the report. Now, when you see reports of EQA for the first time, that might be a bit of a scary experience, but they are not really that scary. They are simple, but they have a lot of information. A lot of it you will almost never use, quite honestly. I've seen plenty of EQA reports, and usually you will be looking for a couple of pieces of information. You will not be looking for everything. So generally, they are simple to interpret, okay? If you have problems, you might do well to know some extra information, but generally, you do not need to have a very deep knowledge in these reports. The most important thing for you to understand in an EQA report is something called the SDI. or standard deviation index. It is the parameter that shows you how accurate your report is. And remember, EQA is mainly meant to assess accuracy. So SDI is the most important in statistics. Another name for SDI that you might see is the Z-score. So Z-score, SDI, two names for the same thing. There is absolutely no difference. Okay? So how do I calculate this SDI? It's a very simple formula. You don't need to memorize the formula, but it will be good to know. So SDI or Z-score equals the result that you have obtained when you have analyzed the sample that you have gotten from your provider, minus the mean you are comparing to, or the reference value, let's say, that you are comparing to, divided by the standard deviation of all the other labs. All right? There are some details, but there's no need to discuss all these details in depth. So your result minus the reference or the target value divided by the standard deviation. Now, the result you will get will be expressed in SDI or Z-score. And later on, I'll explain to you what does that exactly mean and how do you interpret that. So what is this reference? If I go back to the previous slide, it says your result minus the comparator mean, or the reference. What does this reference say? What is this reference exactly? Now, when you get your EQA sample and you analyze it and you compare it to other labs, all the other labs that run the same sample are your reference. Their average values are your reference. Let's say you are one lab out of 100. So you compare your result to the 99 other labs, their average performance, the average performance of the 99 other labs is your target value. And we call this the mean of the peers if the other labs are using the same system and reagent as you are. Okay, so I can only call another lab a peer if they use the same system and the reagent as I am. A Compact Max with PTT Automate is a peer if I am using Compact Max and PTT Automate. But if I'm using Compact Max and PTT Automate, the other lab is Compact Max with CK that's not a peer anymore. Okay, they must have the same system and reagent as you have. An alternative will be, if I don't have peers, I can go to the mean of the method. What does that mean? I'll explain. And then there are other alternatives. We'll explain in detail. The best comparator for you is the peer because they use the same analyzer, the same reagent. As you know, if you change the analyzer, you might get different results. If you change the reagent, you might get different results. So you'll be comparing to something different. Your reports will be failing, but the failure is not your mistake. You are just comparing to the wrong lab. Okay, so the peer is the best thing to compare to. We will go in details a little more. So when do I use the peer? When do I use the method? When do I use all of this? So always we will start our comparison to the peers, to the other labs that use the same analyzer and the same reagent as I do. That is the best comparison you can do. If you have very few labs who are peers, let's say it's a reagent that is used rarely, it's an analyzer that's used rarely, you have less than a certain number of peers. What do? You compare to the method, or you can compare, for example, to people who are using the same instrument. Who decides? It's the provider. So for example, CAP does the following. We start comparing with the peers. If you do not have enough peers, okay, we can start comparing to people who have the same instrument. You don't have a lot of people who use the same instrument, we can compare to people who use the same reagent. However, Randox, for example, does it a little differently. If you have enough peers, good. You don't have enough peers, I compare with everyone who's using the same method. Let's say if you're using, for example, photometry to detect clots. Okay, so it's done a little differently from one provider to another. So there is no standard approach. This approach is determined by the provider. How do I know how this provider works? You have to read their user manual. They will tell you exactly how they do it. Okay, so there is no one process that everyone does, but basically it works more or less the same. Always I start with the peers, not enough peers, I use the next best alternative, but the peers are the best comparator. So To give you an example, I relied mostly on CAP guidelines because they are the clearest, honestly, to work with. So I have a CAP result. I want to submit it. I get my report. CAP says, "Oh, you don't have enough peers." How many peers are enough? For CAP, it's 9. So if I have at least 9 peers, 9 other labs who use the same reagent and analyzer, you will get the result. If you have less than 9, they say, "Okay, fine. We will switch to the next best thing," which is, let's say, people who use the same instrument as you do, or people who use the same reagent as you do. Okay, so that's how it works. But again, the specifics will be given to you by the user manual of the AQA provider. It's too much detail, so I avoided adding it here. This is, for example, I think this is a recast report. I receive a recast report. So they sent me their sample, I analyzed the sample, I filled the sample, I got the report. This is the report. So first, I will start with the peer, number 1. If the peer, which I have 11 peers, as you can see, n is the number of peers, so I have 11 peers, I can compare to my peers, very good. I get the result, etc., etc., etc. Things are fine, okay? For example, here for you, as you can see, the SDI when you compare to your peers is minus 0.51. It's good, I'll explain to you how do we decide it's good later on. So we compare to the peers. However, if you have less than 9, we have to compare to the next best thing. Next best thing will be the methodology. The CPC is the methodology. We have 144. If we have less than 9, we have to go to the next best thing, which is all methods. So I'll be comparing to all methods. Okay, so I start with the peers. I don't have peers for recast, for example. I will go to CPC. I don't have enough people in CPC. I will go to all methods. That's how it works. And again, you have to check with each individual provider to know how do you do it. Okay, now how do I judge if my results are acceptable or no? If you remember again, SDI is the main criteria for you to know. SDI is acceptable if it's between +2 and -2. Who decides on that? ISO did. Okay, of course, there is more details to that, but simply if your SDI is between +2, -2, you are good. Your survey is acceptable. Your AQA is acceptable. So for example, if I go to the previous report, this one, the SDI was minus 0.51. Okay, SDI or Z-score is the same thing. So SDI was minus 0.51. Is it within this range, +2 to -2? Yes, your survey is acceptable for this parameter. Done. Finished. Pass. Now, why does it say minus 0.51? So when you get a negative SDI value, means that your result, the value that you have obtained from this sample, okay, this particular sample that this lab got, they got a minus 0.51. This means that your result, which is in this case 3.79, is below the mean for comparison or the mean of the other labs. So when your SDI is negative, means your value is less than the mean value. If you get a positive SDI, means that your value is higher than the mean of the other labs, or the peer mean, or the method mean, whatever you are comparing to. Okay, so positive SDI means you are higher. Negative SDI means you are lower than whatever reference you are comparing to. And again, we are acceptable between 2 and -2. Now, this is part of something that you might commonly see. If your SDI is constantly negative or constantly positive, you might have to investigate what's going on. All right, we will come to that part in the few coming slides. Generally, you do not have to worry. As a rule of thumb, you do not have to worry about your Z-score or SDI as long as they are within 1.5 and -1.5. Once you start to exceed or drop below the 1.5 mark, things might start to be problematic. So again, as long as your SDI is within 1.5 and -1.5, usually you do not need to check anything. I know that I said 2 to -2 is acceptable. That's acceptability. Okay. What I'm saying is for you to be on the cautious side, to be careful, to avoid issues before they happen. If you are between 1.5 and -1.5, generally you are fine. You don't have to investigate anything. And by the way, This is CAP who says that, okay? So CAP tells you if you are within 1.5 to minus 1.5, life is good. You don't have to bother with investigating anything. Okay, so we will go on into the troubleshooting bit just after a quick introduction to what CVL is. Now, usually the externally quality assessment you are used to is I get a shipment from, let's say, CAP. It has few vials. I run the few vials. I submit each result to CAP. CAP sends me a report for each of these vials. This vial is okay. This vial is okay. This vial is fine. Okay. But it's just this vial is acceptable within this range. It's like running your QC in a way. There is something else. There is another type of survey, which is called CVL survey. In CAP, it's called CVL. CVL is calibration, verification, linearity. Calibration verification is for accuracy. Linearity is obviously for linearity. The regular assays that you are getting from CAP do not do this, okay? Usually they're just samples, as I said, within the SDI range, you're good, finished. Calibration verification and linearity are different. So calibration verification assesses your accuracy over the analytical measuring range. The samples you normally get from CAP or Biorad or Randox do not always cover the whole measuring range. The CVL assay usually covers your measuring range, and the linearity part is for linearity. So the calibration verification is assessing accuracy over your entire analytical measuring range, which is the measuring range of the analyzer. Okay, for example, for fibrinogen for liquid fib, it's 40 milligrams to 1,200 milligrams, or 800 if you want to be specific about it. Okay, linearity is linearity. And it's different. When you want to order the CVL survey, you have to order it with a different part number and you have to have a different payment. It's a different price. It's a different survey. So, as I said, CVL allows you to check accuracy with the calibration verification part, and the linearity allows you to check the linearity part. The reports, let's see, I did not want to go through the specifics of this report because they can be quite a lot. I would advise you to read the guide from, for example, CAP or Biorad or whoever is the provider to understand exactly how they evaluate this. For example, the calibration verification part for CAP, they use the CLIA total allowable error limits in many cases to evaluate your performance. So for example, you will get 3, 4, 5 vials, let's say, and you run each of them. They have different concentrations. Each of them will have its own acceptable range. For linearity, you will get the same vials, okay? You run the same vials for calibration verification and linearity. For the linearity, there are different statistical tools that are used to evaluate your linearity. Calibration verification is evaluated differently from linearity. The specifics, the statistics are a little complicated, and it's beyond this presentation, honestly. If you would like to know them, I can provide you with the details later on, but it's not the place in this presentation to do this. Okay, so what are the common issues that you might face when you're doing the EQA part, either the regular samples, the proficiency testing, or the CVL ones? So we have your SDI for one of the samples in a cycle is out of the SDI limits. I'll explain the details. SDI for all your samples is biased. SDI is completely out of the limit. The results are way too high or way too low. And finally, the CVL survey has failed on one or multiple vials. Because remember, with the CVL survey, you get usually multiple vials. So let's start with issue number 1. But before we start with any of this, I have a couple of slides with important notes. Now, one very important thing to keep in mind, and unfortunately, you will see it often with customers. When you have issues with your EQA, inspectors expect the lab to investigate and provide evidence that you have investigated. If you read the CAP guidelines, they tell you when you have an issue, you have to investigate and you have to provide an evidence for your investigation. You cannot just tell the inspector, oh, I investigated, but where is your evidence? You have to provide the evidence. Now, sometimes you might not be able to find the exact root of the issue. Some issues it will be impossible for you to really find the root cause. The inspectors do not always expect you to find every root cause for every issue. They understand it's not always possible. You need to at least show them that, okay, I have this problem. I have done this investigation. Here is my evidence for the investigation. Okay. And based on this investigation, I found, for example, that my analyzer is okay. So where is the root cause? Maybe the sample, maybe the storage, maybe this, maybe that. At least you show them that you have done your part. So this is very important to understand. You cannot always solve everything. This is the reality of it. The other part is when you are investigating EQA issues, it's very important to pay attention to sample handling, the sample analysis, or the data entry. You will be surprised by the amount of issues that turn up to be just a problem with data entry, or someone mixed up the wrong vial, or someone used the wrong survey. There is really no problem with your system. There is no problem with the materials. It's just someone who made a mistake, and a lot of these mistakes are data entry errors or clerical errors, or someone labeled something wrong, for example. Okay, so these issues are very common. These issues are very important for you to suspect, especially when the results do not make sense. So for example, everything is fine, and one of the results has an SDI, for example, of 15, 20, 50. That does not make any sense. You cannot have this much bias, and everything else is fine. QC is fine. So you can start to doubt these things when you have results which are not very logical. So the problems that you are most likely to face, one of them is I receive multiple samples in my EQA. All right, sample 1, 2, 3, 4, 5. I run them. I receive my report later on. Okay, the report says sample 1 is okay, 2 is okay, 3 is, oh, something is wrong with the 3, it's out. 4 is okay, 5 is okay. Now, how do I work with this? 4 samples are okay, the 5th is not okay. So what are my corrective actions? Because the customer will say, I have a problem with cap. You have to fix your machine, you have to give me a corrective action. What's your corrective action? Now, generally speaking, if one sample out of multiple ones in your survey is problematic, usually that's not a real reason for concern. Okay, usually these are outliers. And by the way, again, this is what CAP says. If you check their guide for troubleshooting, they say if one sample is problematic, just try to make sure that it's not something that is systematic or problem with the precision. And that usually is not a reason for concern, not a big reason for concern. Okay. So usually we would doubt that this sample is an outlier. Now this sample is expired, we cannot use it anymore. So usually we would say, okay, it's likely an outlier. Fine. What can we do? The customer will say, okay, at least I need to do some troubleshooting. At least I need to do something. In this case, you can run repeatability and, for example, use a patient sample, run it 10, 20 times. At least you verify the repeatability is okay. And the second thing that you can do is check the reproducibility of the QC. Is your QC over the last 3, 4 weeks or over the couple of weeks where you run the EQA sample okay? Are the CV percentages or SDs within the manufacturer claims of reproducibility? If yes, usually this is an outlier. Okay, and now you have provided an evidence that you didn't have a problem with your system's precision. Case closed. All right. All right. Second problem. I have multiple files for this survey. I receive my report. The report says most of your samples are on one side of the mean. Now, one side of the mean, how much? How much is my SDI before I start to worry? If you remember, I told you CAP recommends that if your performance for the SDI is within 1.5 to minus 1.5, usually you are okay. Okay, even if most of your samples are on one side for this particular survey. However, if one survey is negatively biased, second survey is negatively biased, third survey is negatively biased, no, you clearly have a bias that you have to investigate. Okay, if one survey is negatively biased, okay, then okay, we can check a few things. Next survey is fine, that's it, case is closed, no problem. All right, but generally, for one particular survey, if your results for the SDI for most of your samples are within 1.5 to minus 1.5, you don't have to worry much. You do some troubleshooting, check few things, but you don't have to dig very deep. Okay? I can check, for example, how was my QC on the date of the analysis? How did I prepare the sample of the EQA? Did I prepare it according to specifications? Was the sample stored according to specifications? Did I run it according to specifications? Did I handle it properly? Yes. What else can I check? I can check, for example, my expert QC. Do I really have a bias? Because again, remember, the QC will not show you biases unless you have very, very severe biases. We said your QC, your internal QC, is not a very good tool for accuracy. So what can I use? Your externalized IQC is one of your best friends when it comes to investigating EQA issues. So I submit my expert QC report. My expert QC report comes back and says, everything is fine, you don't have a bias. Then we can use this as evidence that, okay, my analyzer is okay. It could be an issue with the sample preparation, could be an issue with the sample storage, could be an issue with the samples themselves. They have been, for example, transported to you improperly by the provider, etc., etc. But the idea is you have an issue with the QA, you have to provide evidence that you have done an investigation and that you have evidence that your analyzer is fine. So we did our investigation. We checked that we have no clerical errors. We handled the sample properly. It was stored properly. We have prepared my expert QC report. We have no biases. Okay, so we have an evidence that we have checked our system, that it has no issue. And then one further step that you can do, you can compare your analyzer that has a suspected issue with another analyzer that runs the same survey and that did well. Okay, so I get a multiple samples, let's say 10, 20 samples. I run them on another analyzer, the same analyzer as I have with the same reagent that I have, okay? And that analyzer must have passed that survey. So we compare these two analyzers. If both analyzers give us comparable results, that's further evidence that I have no problem, no bias with my analyzer. Okay, you can present that as evidence to the inspectors, and that usually for them is acceptable as evidence to show your analyzer is okay. No problems are there. Then you wait for the next cycle or the next survey. Next survey is fine, case is closed. No further investigation is required. All right, third case. Your SDI or Z score is out of the limit, is out of the 2 minus 2 range for some or all of your samples, and the results are very high. They're illogical. And usually when I say very high, I usually mean above 3 or 4 SDI, because very rarely you will have a bias that is so significant, okay, that will not reflect on your QC. Usually if you have this much bias, your QC will be clearly biased, will clearly be problematic. So usually when you start to see SDIs of 5, 6, 7, 10, 15, 20 or more, no, that is usually almost always user error. They entered, for example, the wrong unit. They used the wrong vial or the wrong materials. They put the wrong number when they're entering the values. Okay, or another less likely possibility is that the materials are completely damaged or deteriorated, or at least some of the materials is completely deteriorated. So almost always when I have seen these cases, or almost always when these cases are reported, and there is studies about this, it's almost always a user error. Okay, again, they handled things incorrectly, they prepared things incorrectly, they entered the data incorrectly, they labeled things by mistake. Less commonly, it's a problem with the materials themselves. For example, one of the common issues that we'll talk about is some frozen materials from CAP. Some customers usually they receive them thawed. So don't expect your results to be good for a material that you are supposed to receive frozen and you have received it thawed. We'll discuss that later on. Okay, CVL surveys are a little more difficult to work with. So when you are working with CVL surveys, as I said, the calibration verification linearity surveys, you will receive usually 5, 6, 7 vials. Okay, because we said we verify accuracy over the analytical measuring range, so you need different concentrations. And when you work with linearity, usually you work with 5, 6, 7 different results to check your linearity. So you receive multiple vials. Now, how do I investigate the issue if one of my vials failed or if multiple vials failed at the same time? We will take it on two scenarios. First scenario is the highest sample failed or the lowest sample failed, or let's say the last two samples failed, or the last highest two samples failed, or the lowest two samples failed. How do I deal with this? So only the extremes, one of the two extremes failed. Now, when one of the two extremes fails, usually this is not a very good sign. You need to investigate your system if it has a problem. That can be sometimes, not always, that can be sometimes a problem with your reagent, can be a problem with your photometry. It occasionally can be a problem with the CVL materials themselves. But this tends to be a problem with the system. What do I do? The best thing you can do in this case is for the linearity part, if only your linearity fails, you can use your own materials in the lab, like very high samples or cryoprecipitates, for example, to run a linearity assay. Again, the details can be a lot and can be complicated, so this presentation is no place to study exactly how it's done. If you ever face this issue, I can tell you, for example, how to work with it. Sorry, we're in the first scenario. Okay, but again, this presentation is no place to discuss the exact details. So usually if the highest samples or lowest samples are failing, usually that's not a very good sign. You need to run your linearity again, but using different materials because you don't always have the luxury of ordering new materials. That will cost you money. Okay, moving into the next scenario. If I have one or two samples in the middle which are failing, what do I mean with the middle? So if we have 6 files, okay, we have lowest dilution, higher, all the way to the highest dilution. Lowest dilutions are fine, highest dilutions are fine. The ones in the middle are failing. Something is wrong with only the ones in the middle. This is not a very common thing, okay? It's not something that you would normally see, and it doesn't make sense. Because if I have bias, for example, or my samples will be biased. If I have problem with my photometry, usually the extremes will be failing, not the results in the middle. So what do I do? Again, we can use our own samples, okay, to verify the linearity. The specifics, again, if you have this issue, we can discuss exactly what is the protocol that you can use. There's different ways to check this. The second important thing that you need to check for is, are these materials deteriorated? Because this finding results to fail in the middle, or the middle concentrations is not normal. So it's very important for you to verify the stability of the materials. Were they thawed when I received them? Were they prepared correctly? Were they run correctly? Okay. We can also check other things, such as using the calibrator with multiple dilutions, externalized IQC. This issue usually is more complicated. So there is not one approach that fits all. So when you have this issue, there is not really a standard approach for you to work with it. So it's important when you see this kind of scenarios, you have to be careful. You cannot tell the customer it's this or that. You have to closely investigate and you have to exclude variables one at a time because really there is no standard approach in this case. So you have to be careful with it. Now, in either case, when you have either of these issues, you have the extremes failing or you have the middle failing. One very good approach that's not always possible, that's why I left it to the last slide, that's not always possible, is to run a comparison with another system that passed the CVL survey. Not everyone uses CVL surveys, so sometimes you cannot really do this kind of comparison. It will be very good to do a comparison with another lab that passed the CVL survey. And it will be very good to use samples for the comparison close to the concentrations that have failed, because assuming that your system really has a problem, your photometer is not working, it doesn't measure very low concentrations. If you compare your samples with a normal concentration to another lab that passed the CVL, you will not detect the issue because your samples are at the wrong concentration. So usually when you run comparisons to further verify your system, better have samples with a similar concentration to the ones that failed the CVL. Otherwise, you will get the wrong idea about your system performance. That's not always possible. Sometimes samples with these concentrations are not available. That's why I told you this situation sometimes is difficult when it's the CVL that is failing. Now, if you remember, I told you we have one particular issue with cap samples which are supposed to be frozen, which are received thawed by some customers. Now, this is the cap CVL survey with the code LN44. LN is linearity. LN44 survey is for fibrinogen from cap. LN44 is supposed to be received frozen. More than once, I received a complaint from customers that my fibrinogen results are biased. My fibrinogen results do not make sense for CVL. What's the issue? We need to do troubleshooting. One of the first questions you have to ask the customer, the materials that you have received, were they frozen when you have received them? Many cases, the answer will be, oh no, they are thawed or partially thawed. Those materials are no good. Usually they'll give you very bad results. And this is an issue with CAP CVL. I really don't know what is the root cause. I have been unable to get a real answer to this question. Okay, so this is a common issue that you might get with the CAP CVL survey LN44 for fibrinogen. So be careful with this one. The second one is a survey called LN36. Again, it's CAP CVL. This one is for heparin, specifically unfractionated heparin and low molecular weight heparin. The issue will be mostly with the lowest dilution, the lowest concentration, sorry. Now, what's the exact issue with this one? The lowest concentration from CAP comes at a dilution that is below 0.1 IU per ml. Our system does not report heparin below that because your printout limits are 0.1. Okay, what do we do? Now, in CAP, you have an option to report the following. If your analyzer does not report below a certain value, you put your result as below 0.1 in the CAP report. Okay, that can be evaluated by CAP. So if the customer insists that, no, I don't want this, that's not acceptable. Some customers do that, unfortunately. You can do the following. You can create for them a special procedure or a special methodology. You can call it, for example, heparin for CVL or whatever it is that you want to call it. But you tell them you only use this methodology for CAP samples, never for patient samples, okay? Because below 0.1 is out of our analytical measuring range. You should not be reporting sample patient results below 0.1, okay? So you create a special methodology. You call it CAP, you call it whatever you want, and you can put the printout limits from 0 to 2.0. Okay, because this is the analytic, the 2.0 is the upper measuring range for this assay. So next time they run their CVL LN36, they can get values below 0.1, report them, and they have no problems with the report. It's not really a problem. If you report below 0.1, you will not really have a problem with your CAP report. Okay, so this is very important. But remember, the patient methodology, the methodology used to report your patient samples should be unchanged. Do not touch it. Do not change the printout limits, please. To give you a small example of this LN36 issue. Now, this is LN36, sample 7, okay. Assay 1, assay 2, this is your results. You run them in duplicate. First result was 0.1, second result was 0.1, because the analyzer will not allow you to report anything below 0.1 because of the printout limits. So your mean is 0.1. When we compare it to the other participants, okay, it's not really, there's more details to what this target exactly is, not our discussion, okay, but this is your target. So 0.1 compared to this target will fail the evaluation. So the customer will be like, no, this is failed, this is not acceptable, this is not good, according to them. But for CAP, you can report less than 0.1. You can explain to the inspector, this is our analytical measuring range, no problem. So in this case, as you can see, 0.1 is far from 0.037. If your customer really insists and they do not accept that you can report it as below 0.1, you can create for them the methodology that I told you about here. Okay, and that special methodology only is for CAP, nothing else, never for patients. Okay, now we have some FAQs that I will just briefly give you. If you have any notes, any questions about these, please note them down so we can discuss them after the presentation is finished. So we have 10 quick ones. Now, this is the thing that we spoke about first. When do I need to use EQAs? Okay, the first reason is if you have an accreditation by ISO, by CAP, by JCI, by RCPA. It depends on your country and your accreditation. The other reason is if your local authorities require you to do so. So, for example, in Dubai, all labs are required to have an ISO 15189 accreditation, and that requires you to use EQA. So because your local authorities require you to do so, you have to get an EQA to pass. The question number 2, how do I handle the EQA samples? How do I prepare them? How do I run them? How do I aliquot them, etc., etc., etc.? This will be always given to you by the provider. You have a user manual that comes from the provider. It can be an electronic one. Now, again, if you have results that do not make sense or issues that do not make sense, please double check if the customer handled, stored, prepared, worked with samples properly. This is a very common cause of issues. Okay, make sure they use the correct reagent when they enter the results. They use the correct values, the correct units. These are all common mistakes. Now, question 3. Does Stago offer any EQA solutions? Yes, that's Equalers. Now, some customers will tell you, no. How come Stago offers an EQA solution? An EQA solution must be from a third party. That's not true. It must be certified by ISO, and the number of the certification is 17043. It must be certified by ISO as a PT provider or a proficiency testing provider or an EQA provider, all the same thing. So if a company has an EQA certification from ISO, then they can legally work as a PT provider. You don't have to be a third party. Okay, this certification certifies that you are, as an EQA provider, are separate from the interests of the mother company. So the Qualeris has this certification, and this certifies that the Qualeris is independent from the commercial interest, let's say, of Stago. Okay, there are rules, there are ways to check that this is separate from Stago commercial interests. So Qualeris is can be used as an EQA, just like ECAS, just like RECAS, just like RCPA, just like NICAS, just like all the others. No problem whatsoever. The only thing is you cannot use Equalers for CAP because CAP requires you to use only CAP materials. Okay. And one thing, Qualeris offers you a very, very wide range of assays that a lot of the other providers do not have, especially for specialty assays. Now, PT, PTT, fibrinogen, everyone has that, but the specialized assays, not everyone has them. Qualeris does. Now, this is the thing that I told you just about a minute back. If your customer is CAP accredited, can they use Qualeris or RECAS or ECAS or others? Question is no. I have a communication with CAP that I can provide you with. Do you, as CAP, allow the customer to use any EQA providers? They said no. Only CAP, and that's it. All right? Because when you have a CAP accreditation, you have to have CAP EQA program running for at least 6 months before your application starts. Okay, so that's part of CAP accreditation requires. So you can do nothing about it really. This does not apply to CVL surveys. That's a different story, but you can have tools similar to CVL. They do not have to be necessarily from CAP. The ones from CAP are the ones, if you remember, I told you, you get multiple vials, you run them, it says SDI, you are within the range of SDI, you are pass. Simple as that. It's the thing that you think of when you think of CAP samples or RECAS or ECAS. Now, one of the questions you might get from your customers is, which is the best provider for EQA? There is really no real answer to that because it really depends on many things. For example, you can buy from CAP, but CAP is expensive. Do you really have to buy from CAP? Another problem with CAP is that you don't get surveys very often. You get them 3 times a year sometimes for some of the parameters, whereas, for example, ECAS, Equalers, RECAS, they can give you once every month. It's much better to verify your EQA or accuracy with EQA every month than every 4 months. Okay. The cost is a factor, the availability is a factor, your liquor regulations is a factor, so there is really no one answer. Okay, but it's good for you to know this information. Now, How often do I submit my results? Okay, some providers, they actually ship you all the cycles or the samples that you will run for the next 6 months. How often do I run them? Do I run them once every month, once every 2 months? That depends on the program that you are participating in. Again, your customer should have a very clear idea. They do not. If they ask you, when do I do it? Okay, then you have manuals from each provider that tell you exactly when to submit that. And usually customers, they have access to portals that tell them this is when your next sample is due, so they should know. Now, this is very important because you might end up with a disaster if you don't know this information. When you are working with PTT Automate and your customer is a CAP accredited customer, you receive the materials from CAP. You run them on PTT Automate because you are using PTT Automate for your APTT and you want to submit your result. When you get the result for the CAP vials from PTT Automate, you have to multiply the result by 0.85 before you submit it to CAP. Okay? Any CAP sample that you run and you need to submit with PTT Automate, you have to multiply by 0.85. I'm talking about APTT parameters, okay? Only APTT and only CAP. Never for any other reason. You never multiply PTT Automate result by 0.85 except when you are submitting a CAP result. That's the only time you do this. What's the reason? The reason is historical, really. Okay, that was long time back, and it's a practice that is stuck, and it's not something that can be changed now because everyone is following it. It will be very difficult to stop this practice. That actually started when CKPrest was still available. PTT Automate was a new reagent. CKPrest is much older than PTT Automate. So when PTT Automate was introduced, there were very few participants. So they needed to compare PTT Automate results to CKPrest results. And PTT Automate results are usually higher than CKPrest. So there was an agreement, CAP and Stago, okay, the customers will multiply by 0.85 for PTT Automate, and then we'll submit the results and we will compare PTT Automate to CKPrest. But that was a very long time back. Now there is no need because a lot of people use PTT Automate, but unfortunately this practice is stuck. It cannot be changed. So again, PTT Automate results only exclusively for CAP surveys has to be multiplied by 0.85. There's a customer letter. If the customer says, I want a proof of this, I can give you a customer letter. Okay. You can give it to your customer, no problem. Now, question 8. If your customer says, I'm not so sure of the EQA results, I'm not so sure, this feels too high, this feels too low, I want to check with other labs how they are doing. Okay. First of all, it's not recommended for you to repeat the EQA samples because the whole idea is for you to run them same as you do your patient. You can only repeat them if you repeat all your patient results. Okay, so if you run every sample twice, you can run the EQA twice. Okay, because the whole point of EQA again is to be tested exactly the same as your patient results. No changes. Okay, and this is mentioned by CAP specifically. The other point is you should never compare your results to another lab before you get your CAP report. Why? I need to know if I'm performing well. Maybe I'm not doing very well. If I check with the other lab, I detect my mistake. What if the other lab has a mistake and you're the one who's doing well? So now you do something that you're not supposed to do, you change your results, then you get a bad result. And then you have to do corrective actions. It's a headache. Now, always with EQA, all the providers and the regulations actually, they tell you to never compare your results to other labs, even if you are within the same group. It's a group of hospitals, they are all within the same group. Okay, no, you don't compare to others whatsoever. Now, one question that I got recently is, I want to submit my results for Start Max, for CAP, but there is no Start Max in CAP. Yes, that's true. Start Max at the moment is being or listing the Start Max in the CAP analyzers list is being discussed with CAP. There's a longer procedure to be done, and there is a bit of delay from CAP side. So the thing that can be done is for your customer to submit their Start Max results under the Start 4 or Start 8 series. And a lot of customers do that. They get fine. The results are okay. No problem. Okay. But at the moment, Start Max is not really listed in CAP, so don't be surprised if you don't find it. All other analyzers are Satellite Max, Compact Max, Star Max are all listed. No problem. That's the question. How do I interpret the reports of the EQA providers? Now, as I told you in the beginning, the reports generally are simple because usually all I care about is the SDI or the Z-score. If your SDI or Z-score are okay, done, finished. Okay, there's not that much to do. Now, each manufacturer or each provider have their own guide. I have collected for at least the major ones, the guides. I put them in a package with these presentations that I'll be sending you, and you can take a look at them. So for example, the customer might tell you, what does this parameter mean in this report? What does this mean in that report? You will not have an idea unless you check the guide or the user manual of this provider. So I'll give you this. If you have any questions or any concerns, you're always welcome to let me know if you cannot find a certain document or something is not clear. If I don't know myself, I will go get this information for you. And that's it for now. Thank you very much. If you have any questions, please let me know. So does anyone have a question?
Thank you, Live.
You're very much welcome.
No question from my side. Yeah.
Okay, my friend Radi. And by the way, welcome.
The only thing that I wanted to check you is it the recordings. Are we going to get these recordings or?
Of course, I will upload it to YouTube. All of these presentations, Radi, are on a YouTube channel. Okay, just to keep them easy for access. And I'll share it on the WhatsApp group that I added you on.
Okay, no problem. Thanks.
Okay.
Thank you, Les.
You are very much welcome, my friend. So I assume for everyone it's clear?
Yeah.
Yes.
All right. Okay. Then I'll share all of this, inshallah, on the WhatsApp group. And that's it. See you guys, inshallah, in the next one. And please let me know if you need anything.